Welcome back, everyone. Hope you had a nice weekend. Congrats on finishing assignment 4. So today I want to finish off module 4 by continuing with our scikit-learn missions. But before we get into that, does anyone want to bring anything up for discussion or anything about, or do you have any questions about the material so far that you'd like to talk about? Head shaking. That's a no. Okay. Excellent. Okay. So on Friday, when we left off, we had divided into 3 groups, and you were working on the first 3 scikit-learn. Let me paste the link to the Zoom chat. Okay. It's also on Gare. And so those first 3 scikit-learn missions were all related to the Titanic dataset. So I want to spend the rest of today's class working on those missions. And then once it seems like things are converging, we'll have each group walk us through what they did. And then that'll either happen today near the end of class or on Wednesday at the beginning of class, depending on how much time different groups need. So I'm hoping you remember either your groups or your mission numbers, but I'll open up 3 breakout rooms and let you self-assign yourselves. Any questions before we go off into breakout rooms? Okay, let me create 3 rooms. I'll let participants choose the rooms, and okay, so they're all open. So I'll kind of pop in and out as usual, and go from there.
Previously, for that first step of splitting the data set, and then so this is just copying the previous code. The issue here is this won't run because we've got categorical variables that haven't been converted yet.
Yeah.
And
so sex and P class, right?
Sex class.
Hi, Jeremy.
Hello.
Hello. How's it going?
Good. We were actually inefficiently discussing why my or anyone's bar from the question. Was it the last question? The last question of the assignment 4 didn't match your bar.
Oh, great.
I did everything. I really tried everything. It just doesn't, pick yours. And I just submitted.
Nice.
But Clara fixed it, so I'm just gonna get her code and we'll see what
I don't know if it's actually right, but I did a very inefficient thing and it seemed to kind of look like yours. So I'm trying to figure out if it's why I can't copy it into Zoom.
Maybe Slack.
Yeah, you could Slack it.
I got.
Yeah.
Or you could Gitter it. Trying to get Gitter to catch on. It's the new Slack. Well, what I guess, I'm happy to talk about that if you want.
I mean, I'm interested, but
you want to screen share or something, or how? Yeah, what would you?
But then it was just me. I was just like venting out because, like, oh my god, you know what? Like, I wasted 2 hours specifically on that.
Oh.
But it wasn't too bad. It's just like I kind of lost the track of time, and then it's just like I just realized 2 hours passed. But if everyone else wants to jump on the problem that we are supposed to work on, I'm happy to do it too. I can reach out to you.
So the 2, I can give you like one set of hints. I don't know if they'll be useful, but about that particular problem. The first is that they're not standard 95% confidence intervals. It's like 95% of the data. So 95% confidence intervals are of the mean usually. So like if you take, you know, a random subset of the data, like drawn with replacement, and then you compute the mean, and then repeat that a gazillion times, standard 95% confidence intervals would be like the upper and lower, you know, I guess 97.5th percentiles of those means. Whereas the ones that you show in the problem set, since we haven't learned permutation tests yet, I just had you plot the upper and lower 97.5th percentile of the data. So it's like, you know, 2.5%, the smallest 2.5% of the data, and then the upper 97.5th percentile of the data. So they're a lot bigger than they might be normally. I don't know if that was an issue.
I tried it too, but then there was one bar, there one specific bar that doesn't really match yours.
Which condition was it? One of the 20 item conditions?
The third or fourth one, in the middle. I think
Did
Sarah
your serial position curve look correct?
Yeah. Now that I think it did.
So one thing you can solve that bar graph question by calling the serial position curve. So that was the hint in the problem set. If you notice, like you could use your serial position, your SPC function. The average probability of recall is just the average across all presentations of the serial position curve.
But you don't know average though. Not
what? So you get one average recall per presentation position for the serial position curve. And then if you sum those up and divide by the number of presentations, that's equal to the average recall across all presentation positions, which is just the average recall. So there's a trick in the serial position curve function that like you need to exclude repeated recalls and also only include recalls that are between 0 and list length -1, because there's some weird coding issues in the data set that, so if you didn't do that, there are a small number of instances in the data where people recall like the first item, then the second item, then the first item, and then the third item, something like that. And then if you count the first item twice, then it'll artificially inflate the proportion recalled for that person. So that could give you the wrong answer. And if you coded the serial position curve correctly, but then like recomputed it for the bar graph question, then it's a good way to like double your chances of getting a bug, because you then have to like remember all the tricks that you solved for the first one and then make sure you apply them for the second one. So I'm guessing that's maybe what happened, but
yeah, I think I didn't remove the repeated responses for the same answers. I think that's what Farah said she did, and that kind of got her closer to your bars and your graphs. I think that was the issue.
Yeah, I had the big issue of the third one too, and then I don't know, I didn't realize I could just call in the previous function that I wrote, so I just kind of that was my issue, that I had the repeats, and then once I got rid of them, it fixed the bar. So maybe that's what it was.
Cool. Yeah, that's my guess. Yeah, it's a tricky one.
Unrelated, but just a quick question. The lecture 18 recording from last.
Yes, I haven't posted it yet.
Okay,
It's on my
no worries.
list.
Okay, thank you. I just wanted to see if like maybe you had decided not to post it because it was just all questions about the homework assignment or something.
Nah, I'm gonna post it, but I have to edit it and I haven't had a chance. So I'm gonna.
Oh, no worries.
on my
Thank
list.
you. Should we look
So
at?
what mission are you
Yeah.
working on?
Titanic.
Well,
With, mission-
Second one.
the second one?
Yeah.
Got it. Yeah, so the two tricks here are, so like the classifier code is going to be very similar to the classifier in the problem set. But the extra thing here is, well, there are kind of two extra things. One is some of the variables are strings, and so you have to convert those to numbers. And the second thing is that, so that's kind of the trickiest thing. And then the second thing is just swapping out logistic regression with all these other types of classifiers, but the syntax is exactly the same.
Yeah, that's what we were just thinking. Like we can just swap the different type of classifier and then run it.
Yeah. Yeah, you could even make like a dictionary of the classifier names where the keys are the classifier names and then the values are the classifier functions, and then just loop through that dictionary and apply each value, like, you know, make a data frame where the rows are, well, you can set it up in a few different ways, but you could have the rows be different types of classifier names. And then the columns could be like different runs of your, you know, repeated selecting out random training and test sets. And then the entries could be like classifier performance for that particular training test set assignment for that particular classifier. And then that'll make it easier to produce the bar graph in the end, because you can just do data frame dot bar and it'll make that plot.
Very cool.
Cool. Do you want to keep going with that, and then I'll kind of loop back in a bit? All right. Good luck.
Thank you.
Hello.
Hello.
How's it going?
It's good.
Yeah.
We're currently we're making all of the variables that we're interested in into numbers.
Nice. Are you doing the first mission or the second mission or the third mission?
The third mission.
Third mission. Okay. Oh yeah, great. Yeah, that's great. Any questions, or do you feel like you're progressing and just need to keep working on it? Or okay,
I feel like we're chugging along.
right. I'll leave you to it.
Thanks.
Sure. Hello.
Hello.
How's it going?
Good. So we have a quick question,
Yeah.
which is for class and, well, class, it's first, second, third. And there's two ways we could convert that. We could just say like the P class column, which is just first class is a 1, second class is a 2, third class is a 3, or we could just dummy code it. You know, so you have a first and a second, and then, you know, the third is implicit.
Mhm.
And then similarly for deck, you know, you can imagine deck A is 0 or 1, and deck B is then you know, 2, 3, 4, so on. Or we could dummy code that. And so we were sort of unsure.
Wait,
It's
dummy code,
plausible.
do you mean,
Like
what do you mean
create
by dummy code?
column, sorry, create like if you have first, second, third class, you create
3
a
columns?
first class column, a second class column, and then it's just a 1 or a 0 if they're first or second class, and then if they're third class, there's 0 on both of them, and then that implies it's a 1 on the third class.
Yeah, so so in the like machine learning language, that's like an indicator vector, and that's often a really nice way to code things, when you don't have ordered, like when the class order doesn't like carry meaning. Because what's going to happen with your classifier is going to multiply each feature by some value, like a weight, and then sum all those things together, and then basically ask, you know, convert that to a probability. But it's like a, you know, the lower that number, the lower the probability, the higher the number, the higher the probability. So if you have classes ordered, that implies that like second class acts more like first class than third class acts like first class. So if you think the class orderings are informative, then you'd want to code it as like a single variable. Otherwise, you'd want to just keep the columns separate. And then similarly with deck. So if you think the decks are informative or meaningful in terms of their ordering, then you could you know, assign them 1 through number of decks identifiers, or you could just have like an indicator column for each deck.
Okay.
Or you could do both if you want.
What do you think? I think you would expect them to sort of, you would expect, like, especially with for class, like 2 to be an intermediate between 1 and 3. I don't really know how the deck system works.
I mean, we could just plot survivability by deck, just plot the data.
Just to see.
I'm just not fast at plotting, so I don't know off the top of my head how to create that plot, but you basically have on the x-axis is each deck, and then on the y-axis is its survival rate, and then you could just see, is there just a linear relationship between the two? You know, is it ordered but not necessarily linear in the sense that, you know, the distance between all the decks is not, yeah, is the spacing between the decks the same, or is it not the same?
So I just pasted in a command that I think might be helpful.
Thank you.
Sure.
I hate that Zoom.
Oh, geez, the quotes.
It always does that in Zoom.
Oh.
Okay, yeah, so it looks like deck we might want to make. So I think class, we can make a good, looking at the figures there, you can make a good assumption that that is, we can just convert that to 1, 2, 3. But I think for deck, we'll need to dummy code that. So how do you add so I know there's a get dummies function in pandas.
I didn't know that function. What does that do?
So
oh, so it converts, like a cat. Oh, interesting. Convert to indicator vectors. That's great.
Yeah.
Oh, that's
So
cool.
I just then need to, we would just need to append that to the Titanic data frame.
Yeah. So
I think.
yeah. So one way to do that would be to use get. So I'm looking at the API now. So it looks like if you set the so you can use pd.getDummies of let's see, Titanic of deck. That will get you your, but that's going to be a data frame. Well, what I'm not sure of is whether the Titanic index gets preserved in that operation. It might. If not, then you'd have to set the index of that data frame so to whatever the Titanic index is so that they match up. And then you could use concat to concatenate the Titanic, like, you just pass in a list of the Titanic data frame and then the output of get dummies. And then you want to concatenate it along the first axis. So axis equals 1. And that will give you, those however many columns at the end that are coded by these dummy names. So it'll be coded like A, B, C, D, E, F, G. So let's see what actually happened. So oh, yeah, so it looks like it does keep the same index. So let's see.
All right, cool. Yeah, that looks like it works well.
Great.
Now, do we just throw those in?
Into the classifier, or what do you mean throw them in?
Yeah, do we just
Throw them overboard? No.
when we are sort of selecting, what's the what variables we're training on, do we just say, instead of saying deck, we just say A, B, C, D, E, F?
Yeah. Yeah, so you could drop G. I think so. It's not going to hurt you to include G, even if.
Well, that's perfectly. It's going to be perfectly collinear.
Yeah. Yeah, my guess is it won't hurt you, but you're right that it is. Might even take that into account when it inside the training function, like drop any.
Wait, what's the issue with G?
So you can perfectly predict G from A, B, C, D, E, F.
Oh,
like if you have all zeros in those
Yeah.
columns, then you know what G is. That it's 1.
Except wait.
Sometimes it's nan, or sometimes you
Yeah.
get all nans.
So sometimes it's none of them. It's actually quite often none of them. Or yeah.
Oh. So we probably, first thing we want to do is just drop any rows that have a nan deck.
Yeah, we would want those to be nan for deck.
Well, so I think
No? For each.
I'm not sure how the logistic regression classifier handles nans. Some scikit-learn functions just like if you have a nan for a feature, it'll just give you like the average weight for that feature across all other participants that do have that value. So it'll like predict you're the average for that feature. If it doesn't know it, which is usually fine. Like it doesn't, but yeah, I think dropping nans is also fine. So, you should drop the deck column now that it's redundant with the indicator vectors, and then I guess embarked, maybe you're not using, I don't know. Let's see. Oh, I guess P class is the same as class. It's just that it's
Yeah.
a number.
Yeah.
Okay.
I think we were just going to use P class.
Yeah, I think that's fine.
So I know how to find all the NA columns. Is there a way to get the, it's not NA? Oh, but there's a drop function maybe? Oh, yeah,
Well,
I'll
so
just
you-
use the drop.
You could also say like apply lambda x not np dot is nan of x. So that's a function that will return true if and only if you have a nan.
Mhm.
And then if you apply that to your column, that'll give you a list or a series of trues and falses. And you can do data frame dot loc of that, and that will select out all the non-nan rows. So you can pass an array or a series or a list of Boolean values to index your data frame, as long as it's the same number of, has the same length as the number of rows. Cool. So do you want to keep going with this and then?
Sure.
All right.
Thank you.
Yeah, sure thing. Hello again. How's it going?
Working.
Everyone's muted, so you're having a very intense
Yeah.
discussion. You're all kind of working in
decided to break
parallel.
off. Yeah, we decided to break off and think about it independently for a couple minutes.
Oh, yeah. Cool. Well, should I just head off to another? I don't want to interrupt your solitude. Okay. Well, yeah.
Well, I'm working on the model selection function. Somehow it's not, it keeps giving me the error message. Module skill scikit-learn doesn't have an attribute model selection. So I'm like, what?
Interesting. Model selection.
So yeah, this is what it gives.
What are you using model selection for, though?
To split train and test data set.
So you wanted to find a built-in function to do model selection, or?
You mean built-in in scikit-learn, or?
So I guess what I was thinking for that mission is like you would use the train test split function to divide the data set into training and test parts, and then like train each classifier on the training data, test it on the testing data, get an accuracy, and then just like, manually code the accuracy for each selection of training and test data for each classifier. And then you could do that for each classifier and then just like fill in your table. There might be a way to do that automatically with scikit-learn. I'm sure there is, but let's see.
But Jeremy, this function that I'm using to split train and test data set is I didn't found it on the web. It's from your Colab notebook, the library tool notebook. It's under scikit-learn.model selection.train test split.
Oh, interesting. That's what you're talking about for, okay.
And it worked for the assignment, but somehow it gives a wrong weird error message this time.
Okay, let's see. I see. Here, let me see. So factory reset runtime, reconnect. Interesting. Huh.
Has anyone split the?
It's not working on mine either. I don't know what's going on.
You can't do this.
It worked for the assignment, right? Like,
yeah. Has anyone succeeded?
is it breaking for everyone?
I don't know. I'm having a different issue and haven't gotten to that yet here.
Maybe scikit-learn is, I don't know, having a lot of different issues today with different functions.
But I mean, it's not like, oh, you know what?
So is it named sklearn in this notebook, or is it skl?
I did skl, and it's
Okay.
skl in this notebook.
Okay.
Let's see. Trying one thing. Let's see. Weird. I have no idea. I'm lost here. I'm gonna have to Google this. Weird. Huh. Ah. Um, Interesting. Yeah, it doesn't have any modules in it today. Not for me, at least.
Or
Yeah. I've never encountered this before. Fascinating.
oh, are we the only group who's working with scikit-learn classification? Or?
No, every group is. So yeah, because it's a, yeah. Let me see if the other groups are having any. I'll be back. I'm gonna have to
Cool.
look into this.
Thanks.
All right. Yeah. How's it going?
Still going. We're looking how we could plot a main result.
Oh yeah. You're doing mission 3.
Mhm.
Oh, cool. So you have the results already. So scikit-learn is working for all of you then? Yeah.
Yeah.
Fascinating.
Is it not working?
It's
for
not
you?
working for some people.
Oh,
Or
no.
me, like it's not working in my notebook either. I'm not sure why.
Really?
Yeah.
Oh.
Oh, you know
Well,
what?
only using is this line, the scikit cluster import k-mean.
Yeah,
Well, I
no,
have a whole like import sklearn statement, so I don't know all these other things.
Chris, did you have a idea there?
Well, the first time I tried running sklearn, it said it didn't have a cluster attribute, which it
Right.
does. But then Danica suggested just importing it like in the cell directly, and that worked.
Interesting.
Yeah, that is interesting because I separated my import statements from the rest of the like where I'm using them.
I separated
works
it.
for me.
So I had sklearn before by itself, but it
Mhm.
didn't recognize cluster, so I just imported sklearn. I imported it again.
Weird. So yeah. Yeah, so you can import specific modules from scikit-learn. That works. But you can for the assignment, it was definitely using a different syntax and it worked. As far as, I don't know, did it work for anyone else? Did it work for you all? Did your notebooks just crash for assignment 4? No.
It worked fine.
Yeah. Fascinating. Okay. Interesting. Well, carry on. I'm gonna. Cool. I'm glad it's working for you all. Okay. All right.
So.
Okay, so I have I have a way to get it to work. I don't understand why the other way is not working. But you can just say from scikit-learn import model selection. So if you import the module directly, it will work. If you import the whole library, for some reason, it's not being treated as a module.
Interesting.
Yep, I'm gonna have to Google that one. I couldn't find anything quick, but very interesting. But that's how you can get it to work. So if you just say like this line here, I think this will work, or at least it's working for me. And then you can do model selection dot train test split.
So Jeremy, I just did it, and then it seems like it applies to other modules too. So for example, I'm using SVM and it says there is no module, no attribute.
Yeah. So something is up with I wonder if like some image got corrupted on some of the computers or something. But yeah, because when I just import scikit-learn regularly, like, okay, now it's working for me. Well, it wasn't working before. Well,
this is what it is like working working our field.
Okay, you know what? If you import a specific, I wonder if it's like if you import a specific module, I'm wondering if there's some initialization that like hasn't happened that happens the first time you import a module. Now it's working just like it always does. Yep, so the only thing I did was I imported the model selection module.
Interesting.
Man, that is a tricky one. So weird. I mean, of course it's there, because how else could I import it? Huh. It's like, does this exist? No. Give me that. Okay, here it is. Yeah. Why aren't they the same? Yeah. Okay, well, does it work? I guess the importing individual modules at least works for everyone? Okay, so that's maybe a way to at least continue. Okay. All right. Do you want to play around with that and I'll loop around to the other groups?
Yeah.
Oh. Actually, I'm going to go back to the main room and let Stephen in again. Sorry. Hi, Stephen. Sorry about that. Just got your message.
Thanks.
Don't know how long you were waiting there, but yeah.
Just a minute.
Okay. Sorry about that. All right.
Room 1. Yep.
Cool.
Did anything crazy happen while I was gone?
So I got it running.
Oh, that's a development.
Can you see the prior chat since you left? Or should I put it in again?
No.
Okay. Give me 1 second here.
So it seems like you're maybe close with something.
Yes, I got it running.
Oh, awesome. Okay, so maybe I'll give everyone a couple more minutes and then we'll go back to the main room. All right, I'll see how the other rooms are doing.
Cool. What is going on?
So
Okay.
Hello again. How's it going? Still going. Do you have a sense of like how close you are, or?
We're approaching.
Okay.
Hold
All
on, I have
right.
to look at our goals again. Approaching.
Okay. Cool. All right. I might give people a couple more minutes and then I'll, we're approaching the end of class. So we'll maybe do a check-in even if people aren't done, but all right. So see you in a bit. Hello again. So it looks like the other groups are getting close. So you were on mission 2, right?
Right.
Yeah. So yours is actually yours is definitely the hardest to help make you feel better. Yeah, because you had to basically do mission 1 and then do extra stuff. So, but we'll maybe spend a couple more minutes and then we'll go back to the main class because we're approaching the end of class time. So we can do a check-in and see how everyone's doing. All right, so see you in a few. All right. Hi again, everyone. How did that go? Some thumbs up and some skeptical looks. That's good. Healthy mix. Okay, so well, we only have a couple minutes left in class, so it's probably not enough time to dig into anyone's solution. So maybe we'll, at the beginning of class on Wednesday, do a quick run through of different people's solutions, and then that'll be the end of module 4. In the meantime, yeah, so hopefully by this point, you're starting to build up some general familiarity with pandas and scikit-learn and maybe some of the other libraries. And then I'm also sure that you might be I'm not sure. You might also be appreciating how huge and unwieldy both of those libraries are. But I think at this point, we've mostly gotten sufficient exposure to the key Python libraries that we've covered so far that I think it's now time to move on from module 4 and get to the other stuff. So moving forward, so except for having us go through the your solutions or attempts on Wednesday, we're gonna move on from module 4. As we discussed last week, we're going to skip module 5. So why don't you start going through the material in modules 6 and 7 for Wednesday's class. There's a lot of stuff there. And so you should, what I'd recommend is focusing on the stuff that you most want to know about and then kind of skimming or skipping the rest. So really just kind of let your interest drive you there. And then I'll put some sort of demo together for Wednesday so we can start practicing with data analysis and modeling techniques. Of course, as always, we'll leave time to have anyone ask questions on the material and stuff like that. Yeah, let's see. So maybe I'll well, I'll think of a good demo. I have some ideas. All right, everyone. Nice to see you all and see you on Wednesday. Take care.